Alright, I want to show you the difference between unbounded and bounded solutions. So I'm going to work a couple more of these in 10.9. Now notice 36 has 4 inequalities. So this system of inequalities, you're not going to do anything different than we did on the other ones to solve it, because in order to solve it, you've got to graph the system of inequalities on the same set of axes. And if you look at that top equation, or inequality I should say, you've got 4x plus 3y is less than or equal to 18. So I am going to graph that just like that were an equation, and the easiest way to do that is by finding the x and the y-intercept because it's in standard form. So to find the x-intercept, I let y be 0. So if I solve that for x, then I would get 4x equals 18. Remember, when you're graphing it, you graph it just like an equation. So 4x equals 18, which means x would be 18 over 4. My y value is 0 because this is my x-intercept. And then to find my y-intercept, I let x be 0, and if I plug that in, then I get 3y equals 18, or y equals 6. So I've got my 2 points, and remember, you only need 2 points to graph a line. So I've got 18 over 4, which is 4.5, which is right there, and then I've got 0, 6. So I've got this line, and it's going to be a solid line because that is or equal to, so it's included. And now I'm just looking to see which way I shade. So if I pick a test point that's not on that line, let's pick 0, 0. If I plug in 0, 0, 0 for x, 0 for y, I get 0 is less than or equal to 18. Well, that's a true statement, so I'm going to shade everything toward my test point. So I'm shading everything toward 0, 0, since that made that statement true. All right, now I'm going to go on to that next inequality. And I've got 2x plus y is less than or equal to 8. So I'm going to do the same thing. The y-intercept is going to be, the x-intercept is going to be 4, 0, because I let y be 0. Then when I let x be 0, my y-intercept is going to be 8. So I've got 4, 0, and I've got 0, 8. So I've got that line coming down like that. It's a solid line as well because it's less than or equal to 8. I'm going to do the same thing. I'm going to pick 0, 0. When I plug that in, that makes that true because 0, 2 times 0 is 0 plus 0. So 0 is less than or equal to 8, which is a true statement. So I'm shading everything toward my test point, which was 0, 0. All right, so far I've done 2 of them. Now I'm going to do my x is greater than or equal to 0. Remember that x equals 0, if I'm graphing that, x equals 0, that's a vertical line. It's included, so this is going to be the y-axis. This is a vertical line going through x at 0. And I don't know why I'm dotting it because it should be solid. So it's a solid line, and then everything greater than 0. My x value is greater than 0. Well, that's going to be everything to the right. And you can see, you got to kind of be careful because this is getting a little bit messy, but you can keep going with it. So I only have one more inequality to do, and I have my y is greater than 0. So y equals 0, that's a horizontal line that's going through y at 0. That's also a solid line. So that's going to be my x-axis. And everything greater than 0 is everything above 0 on my y-axis, so that's going to be all shaded like that. Alright, now I'm going to take my black and I'm going to show you where all 4 of these intercept. Alright, so notice that they all 4 intercept right here. Okay, so that's where all 4 of these inequalities intersect. Now notice that all sides of this solution set, this is my solution set, So any value I picked in this black area, I could plug it into all 4 of those inequalities and it would make it true. Notice that it is enclosed on all 1, 2, 3, 4 sides. So I call this bounded. It's bounded because it's enclosed on all 4 sides. Now, if you're trying to figure out what the vertices are just the corners. So I've got a vertex there, a vertex there, a vertex there, and a vertex there. All right, so these, the 3 that are on the corners, are pretty easy to see what the vertices are. However, this is the only one, I mean, this one you can look at. That is 0, 0. This one you can look at. That is 4, 0. This one you can look at. That is 0, 6. And this one, if you can't really approximate, but think about how you would solve this. The intersection of this red inequality and this purple inequality, so this inequality and that inequality, is where that vertex is. It's where those 2 lines meet. So if I'm trying to figure that out and solve it, I would just write this out like, first I would get my pen working, and I would do, why isn't my pen working? I don't know. So I would write this out just like, let me see if I can get my finger to work. So 4x, well, never mind, my finger's not working. I think it's my pen. My pen is about to die. So let me see if I can get it going here. There we go. All right, so we've got 4x plus 3y equals 18. And we've got 2x plus y equals 8. Now I'm looking for the intersection. That's why I'm using the equations. All right, so we're going to set this up just like we would if we were solving a system of equations. The easiest way to do is probably to get opposites here. So I'm going to multiply this bottom equation. I'm going to multiply that bottom equation by -2 to get opposites. So I'm going to have the top equation isn't changing, 4x plus 3y equals 18. And then that bottom equation is going to be -4x minus 2y equals -16. And when I add these 2, those are opposites, so they add out, my x's. And then my y's are going to give me y equals 2. So I've got y equals 2. And then to find x, all I need to do is plug that back in. So I've got 4x plus 3 times 2 equals 18. And just do this simple calculation there. So you get 4x equals 12. So x would be 3. So x is 3. So this vertex is going to be 3, 2. All right, so just to be clear there, graph all the inequalities on the same set of axes. If the solution set is enclosed on all sides, it could have more than 4 sides, but if it's enclosed on all 4 sides, or however many sides there are, it's bounded. And then to find the vertices, if you can't just look at them, if they're not in an axis to where you can just look at them, then solve the intersection just like you would a system of equations.